Hello and welcome all. Today we are going to look at Joule thief circuit. What is Joule thief circuit and how it is working? A Joule thief a Joule thief circuit actually a boost circuit. That means if the input voltage is low, we can increase the voltage. If this is 5 volt and if these LEDs are 3 volt each, then means 6 volt has been needed. So by using this circuit we can increase the voltage and light up the LEDs. How it is working? This is a circuit of LED bulb and we can use this transformer. How we can use this? Take this core and wound the coil in opposite direction. That means if one is in this direction, the other should be in the opposite direction, and one has to connect to the base of the transistor. The second one has to be connected to the collector of the transistor, and this point has to be grounded. Now we will check how this circuit is working. That means when the battery is connected, first the transistor is off. That means there will be no current flow through this. But this side is positive and this side is in a ground, so a current is flowing through this. So when a current is flowing through this and the transistor had a beta, that means if 1 milliampere current flow through this, and if we say that the transistor has a beta of 100, then 100 times current will be flown through this. Why it is so? This means the resistance at this base is 100 times less than this, or the resistance at this point is very high, 100 times high than this. So more current will be flown through this. When more current will be flown through this, as we know that V is equal to L into di by dt. As the transistor is on, the voltage across the inductor will be high. As this on more means the resistance is decreasing, so the voltage across the inductor is increasing. So what happens is that when a current is flowing through an inductor, when a current is flowing through this magnetic core produces a magnetic flux. If the permeability of the material is very high, that means if we use a iron, it produces a high amount of flux. The purpose of the flux is to resist the current flowing through it. So if the iron is used as core, a high amount of flux will be generated to oppose the current coming into the circuit, so that it can maintain the same energy. As the property of physical inertia, the inductor has also the property to remain the energy in it constant. So if more current goes through this, the core has to carry more energy in order to avoid that the magnetic core produces a flux. This is called self-inductance. This flux is linked with this coil itself, produces a counter EMF. When a current is flowing through it, a flux is generated by the coil, and this coil induces EMF which is opposing the input voltage. Now the purpose of the flux is to restrict the current that is carrying the energy and causing the energy change in the core. If the direction of the current is from here to here, that means it is flowing from this side to this. If it is wound from anti-clockwise, the direction of the flux will be into the like this, into, and it is coming out in the transformer. It is like this. That means it is is like this. This also produces a flux. When a current is passing through it, this also produces a flux in the same way. But here it is that the current is low because the base has a high resistance. So the rate of change of current will be very less if we consider the two base current and IC current. For the same time, if it is the time and it is the current, the base current, rate of change of base current will be, if this is say 10 microsecond, in 10 microsecond the base current only reached at this point because the resistance is very high. But at the same time the collector current will be at this value. That means the resistance of the emitter to collector is very less. So a large change in current will happen. So the flux generated by this will be very less compared to this. As the coils are wound in opposite direction, the direction of the flux is in opposite direction. If this coil is wound in anti-clockwise direction, this coil is wound in the clockwise direction. That means, and if this is in opposite direction, this flux will be coming out. So this flux and this flux will be cancelled. But this has a high flux because there is a high current is flowing through this. So this has a high flux, high amount rate of change of flux. This has a low rate of change of flux. So this will cancel this flux. What will happen if this cancel this flux? If this collector inductor current cancel the base inductor flux, what will happen? Why the inductor is when an inductor is why the inductor is showing the property of inductance? Because of the flux generated by the core, it is showing the inductance. When the flux is cancelled by this flux, there will be no inductance in the primary. Low inductance in the primary, and only the resistance is available at this point. And there is no reactive impedance now. Now the base current is increased and the collector current even more increased. So at the high rate of change of current, more high rate of change of flux also available at the core now. And more than that, this flux is so high that it induces a voltage that is not decreasing the current through it, but it helps to increase the current through it. How? When the base current increases, the collector current also increases, and the rate of change of flux in the core due to the collector is also increasing. This flux, when linked with the collector, will oppose the battery voltage. That is, the induced EMF opposes the battery voltage. But when it is linked with the primary coil, that is in opposite direction, this will induce a voltage which is in series with the battery voltage. Now it will look like that two batteries are connected in series. That means the voltage at the base of the transistor increasing, and more current will flow through the collector, and the process will repeat. Base resistance is very high, so the base current is low and the flux is also low. The collector resistance is low, so the collector current will be high and the flux is high, so the dominant is collector flux. Because of the effect of this flux, the flux in the coil, the current in the coil increases. Or we can say that due to this flux, a large flux, the inductance of the coil is reduced, and more than that, it give a voltage in the opposite polarity, so that the total voltage will be this battery voltage plus the voltage created by this. That means minus plus minus plus. That means if it is the battery voltage is 5 volt, and due to this flux this also created a plus 5 volt, then total voltage will be 10 voltage will be at this point. The only thing that resists the flow of current is the base emitter resistance. Now as the current keeps on increasing, the flux in the core become more and more, and the flux is produced mainly due to this flux. This flux is already cancelled by this flux, and even more flux is there. This flux is due to a high flow of current through it, and the flux is stored inside the core of the transformer. As more and more current is going, the flux core becomes saturated. That means it reaches its maximum value. If more current is going through this, coil does not produce any rate of change of flux. That means it reaches its maximum value. The flux is like this. That means the flux is increasing like this, and become at a particular point the core has reached its maximum value. If beyond which the current is increasing, the flux in the core will not increase again, because it does not have any space to occupy more flux. When the change in flux there is no more change in flux, voltage produced by this will be reduced. This voltage will be decreased. The earlier 5 voltages in the battery and 5 voltages produced by this. Now this voltage has gone, so only 5 voltage is available. So what happens is that this point the current through the circuit began to decrease. When the current through the base is going to decrease, the collector current is also going to decrease. This circuit can be compared to this circuit. This is the battery, and this is the positive voltage. This is the coil connected to the base, and this is the coil connected to the collector, and this is the transistor. That means if the resistance is decreasing, that means if more voltage is available at this point, the resistance is decreasing, and it has a beta times. That means if this resistance has decreased a small value, and beta say 100 times resistance will be 100 times resistance will be reduced at this point. There is no base current at starting, so there will be no collector current through this coil. So when the battery is connected, a current is starting to flow through this. When a current is starting to flow through this, the resistance of the base to emitter is decreasing. So 100 times less resistance will be available at this point. So the current in the collector will be 100 times more than the base current. If this is the base current, this would be the collector current 100 times more. If this is 1 milliampere, the collector current would be 100 milliampere. Will flow through this. So as more current is going through this, it produces more flux compared to this flux, and these are in opposite. The coils are wound in opposite direction. This coil produces a flux. If the coil is wound in clockwise, the direction of the flux will be like this. If this coil is on the direction, the direction of the flux will be into it. So because this flux is more, because more current is flowing through this flux is more, this flux will be cancelled. This flux will be cancelled means the reason for a coil to show its inductance is due to the flux. When the flux is created, this flux is linked with the coil that give a voltage that will oppose the input voltage. That is called self-inductance. Because of this flux, this self-inductance of the coil will be reduced. That means this flux will get cancelled, and this coil will be only a wire. There is no more inductance, so more current flows through it, so more flux is generated. Now what happens is that this flux, what is the purpose of this flux? This flux wants to reduce the current flowing into the transistor. As these are in opposite direction, if this flux is linked with this coil, as these are in opposite direction, this flux increases the current. That means if this is the polarity plus and minus due to this flux, as it is in opposite direction, this polarity, when this flux is linked with this coil, the polarity become like this, minus here and plus here, because these are in opposite direction. And more than that, why it is more flux, that is the resistance is very low and more current is going through this, so this flux is more, so it is dominating this flux, and this flux induces a voltage in opposite direction, so more current will flow through this. That means this is minus plus, this is minus plus. That means if this is 5 volts and if you say that this is also 5 volts, total 10 voltage is available at the base, so a heavy current flows through this, so 100 times more current flows through this. That means the rate of change of current will be something like it. At initial point, the rate of change of, if we plot the collector current, at the initial point the rate of change will be very less, and after some time the rate of change, this is time. In this period the increasing current will be very less, but this time the increasing current will be more. This time more current is increasing, and after a particular point it has reached its maximum flux. The core has reached its maximum flux. The core is reached its maximum flux due to this flux, this collector flux, not this flux, this flux. And when it reaches a maximum flux, there will be no more change in flux. There will be no more change in flux. The change in flux is producing a voltage. That means the change in flux is causing more current to flow through this. When it is suddenly stopped, this voltage disappears. That means this 5 voltage disappears and only battery voltage is available. When only battery voltage is available, the current in the base reaches this point. When this voltage disappears, the battery current begins to decrease. When the battery current begins to decrease, the collector current also began to decrease. When the collector current began to decrease, the magnetic core wants to maintain its current. Current wants to maintain its current, and earlier this flux was increasing. Now the flux began to decrease. When the flux began to decrease, the polarity will be reversed. Now it is become minus and become plus here. So it will cancel the battery voltage also. So there will be no voltage at this point. Suddenly the base to emitter junction is closed and the resistance is increased very high. That means the current has no path to go. The inductor current is reached. If this is the base current, the collector current will be very large. The collector current at this point reaches the maximum and it has no way to go. So the inductor does not want to, the inductor maintain its energy by this flow of current, this kinetic energy, this flow, due to the kinetic energy, that means the flow of the electron, this magnetic field is maintained. When it suddenly stops, this collector emitter junction, that means with a high resistance, this current has to go somewhere. Sudden change in resistance. If we say that the change in resistance is, the resistance has changed with a very small time, 5 microsecond, then that the current has reached, if we say that the current has reached a 1 ampere, that means in di, change in current is 1 ampere. So di is equal to 1 ampere, and the time is 5, dt is 5 microsecond. So di by dt is equal to 1 divided by 5 into 10 raised to minus 3, 10 raised to minus 6 is equal to 0.2 into 10 raised to minus 6, 0.2 into 10 raised to 6. This is the rate of change of current. And if we say that the inductance is 100 microhenry, in L is equal to 100 microhenry, 100 into 10 raised to minus 6, then voltage is equal to L into di by dt is equal to 100 into 10 raised to minus 6 into 0.2 into 10 raised to 6. This will cancel and the 20 volt. We will get 20 volt at this point. Now the 5 volt battery voltage is increased to 20 volt. This is how a Joule circuit is working.